All right, guys, today we are going to go over dilutions. So dilutions refer to a solution, so we need to make sure we understand what a solution is. A solution is comprised of two parts, one being the solute, the thing that you are dissolving, and the other being the solvent, or the substance that is doing the dissolving. If you're not sure you need a further explanation on solutions and molarity, please check out my video that's linked above. When we are talking about a dilution, if we think of the word dilute, it usually typically means watery to us. So a dilution is much the same in chemistry. We add a solvent, typically water, to a solution, and that results in the molarity or concentration decreasing. So as we add more and more water, let's say to Kool-Aid, we would expect that the concentration of the Kool-Aid is going to decrease. So sometimes a picture is helpful in understanding what's happening. All right, in my first beaker, beaker A here, you can see that I have some solute particles, the dissolved substance, which are shown with dots. Then I have a volume of liquid here, and I am going to say that that volume is 1 liter. Now, if I want to dilute this solution, I would add water. Let's say that I add water up to the point that I have 2 liters. But if I'm just adding water, I'm not changing the amount of particles that are dissolved. So my solution, even though it has more volume, would still have the same amount of solute. If I'm comparing solution A to solution B, I would expect solution B to have a lower concentration because the ratio of solute to solvent is less. If you're a math person, I could show my ratio of solute to solvent, otherwise known as my concentration, by taking 5 dots over 1 liter. Over here in beaker B, my concentration can be found by taking my solute, again 5 dots, but this time over 2 liters. If I compare the ratio, my ratio here is 5, and my ratio here is 2.5. Beaker B has a lower concentration or a lower molarity. So we can see that adding water to my solution caused the ratio to go down. There's an easy equation that we can use in order to show how much the concentration goes down by. We can use the equation M1V1 equals M2V2. Now, M refers to our molarity and V refers to the volume of our solution. The 1 tells me that it is my initial solution. Oftentimes, that initial or starting solution is often referred to as a stock solution. So if you see that term, stock solution, it's just referring to your starting solution prior to dilution. M2 and V2 represent the molarity and the volume of the solution after the water has been added. So this is my final solution. One helpful hint is remember that you are diluting something, so we are expecting that the molarity goes down. Your second molarity should always be lower than your first molarity, since the purpose of this is adding water to lower the concentration. Let's look at an example problem. I want to know how many milliliters of an 18 molar HCl stock solution are needed to make 150 milliliters of a 6 molar solution. So I like to start all of my math problems by identifying what variable each number represents. This is a molarity, this is a volume, and this is a molarity. It is asking me how many milliliters, and milliliters is a volume. So if you notice, I have 2 molarities and 2 volumes. M1, V1 equals M2. V2 is my equation. I suggest always listing your variables and determining what are your knowns and unknowns prior to substitution. You have to read these problems carefully to make sure that you correctly identify your starting or stock solution and your ending or dilute solution. So let's read through this. I know this is a molarity, but I have to decide if it's my starting molarity or my ending molarity. It says how many milliliters of an 18 molar HCl stock solution. That word stock solution indicates that it is a starting molarity or my first molarity. Then are needed to make. So I'm trying to make this new solution. That indicates that I'm talking about solution 2. The new solution has a volume of 150 milliliters and it has a molarity of 6. So now I know that I'm looking for my starting volume. How much of that stock solution am I going to need? One thing to talk about is our units. You have to have your molarity for concentration, but your volume, it could be in milliliters or liters. It does not matter as long as you make sure that your starting unit and your ending unit are the same. Now that we know our units, we're ready to substitute in. Instead of M1, I'm going to write 18. I don't know my V1, so I'm going to call that X, or you could leave it V1. My second molarity is 6, and my second volume is 150 milliliters. Now, I just need to get X by itself. In order to do that, I am going to divide both sides by 18. My X value ends up being 50, but remember that we need to make sure that we understand what this number means. The unit that belongs on the 50 is milliliters. If your volume ends in milliliters, it had to start in milliliters as well. So we know that we need 50 milliliters. But let's make sure we also understand what that number is representing. This is my stock solution. So what is it telling me to do? Well, I'm going to need to use a 150 milliliter volumetric flask. I would then take 50 milliliters out of my stock solution and pour it into that volumetric flask. Then I would add water. Until I get to the mark that represents 150 milliliters. That final solution, after I've added the water, is going to have a molarity of 6. Let's try a second problem. This time I want to know what is the molarity of a solution made by adding 100 milliliters of water to 250 milliliters of a 0.8 molar solution. So once again, I see that I have a volume and a second volume, a molarity, and it's asking me to find a molarity. As soon as I have two molarities or two volumes, I know I'm going to need to use the molarity equation, M1V1 equals M2V2. Next, I'm going to list out my variables, and I'm going to identify what my starting and ending variables are. I'm trying to find the molarity of a solution that was made by adding 100 milliliters of water to a 250 milliliter 0.8 molar solution. So this is telling me that I'm adding water to the solution that was 250 milliliters to begin with. So my initial volume was 250 milliliters and the initial concentration was 0.8. I want to know what is the new molarity after I add 100 milliliters of water. Now, watch the wording of this carefully. I'm adding 100 milliliters of water to a solution that already had a volume of 250 milliliters. That means that my new solution will be 350 milliliters in volume. Once I've identified 3 out of the 4 variables, I'm ready to solve. Let's plug in. I have 0.8 as my molarity. My volume is 250 milliliters. My new molarity is unknown, so I can call that X, and my final molarity is 350 milliliters. In order to get X by itself, I'm going to need to divide both sides by the 350 milliliters. Whatever I do to one side, I need to do to the other. And that gives me an answer of 0.57. Now, I need to make sure that I understand what that 0.57 represents. So, I know that I was solving for M2, so this is a molarity. When you're done, make sure that your answer makes sense. We know that in a dilution, we're adding water to decrease the molarity. So my starting molarity was 0.8. I added water and the molarity went down as expected. My number makes sense. I hope this helped you understand dilutions. If you want to know more about solutions, check out my video on molarity, and thanks for watching.